Sequence and series. So we have two main sequence and series that we are dealing with. So one is arithmetic and the other one is geometric. Now, in your table, if you please open them to page, I think is 22, there it is, you have a formulas for arithmetic sequence and then for geometric sequence. The main difference between them is that with arithmetic sequence, every time we add a value, so I have a number, I add a value, and then I get the next number. And then again, I add the same value, and then I have the following number, and so on. Remember that I can be adding a negative value, right? Okay. And then the next one, the geometric one, is when I have a number and I multiply, this time by a value. So I take the first one, multiply, get the second. Then again, take the second, multiply by the same number, and then get the third. Now, don't forget that I can be multiplying by, let's say, 3, or I can be multiplying by 1 over 3, isn't it? Which is technically dividing by 3. So anyway, those are your main two difference. So let's have a look. The first two terms of an arithmetic sequence are 3 and 10. So first two terms, so term 1 is 3, and then the next term 2 is 10. So I have 3, and then I have 10, and then other numbers, isn't it? So what do I need to do with it? I need to find the sum of the first 100. So when it comes to the formulas in your table, whether it's arithmetic or geometric, one formula refers to the term, the value of the term, where that term is standing in the sequence. And then the second formula, DSN, is the formula for the sum. Now, here we are dealing with arithmetic sequence, therefore, let's just get that. So therefore, this is the formula for the sum we're going to use. And like with every formula, I need to know, well, what the letters represent. Do I have them? What do I replace them with? Let's just take that below. So N, this is how many terms, number of terms I am adding. Then I have A, that's my first term. And then I have D, that is that number I'm adding every time, what's called a common difference. So do I have how many numbers I am adding? 100. So yes, value of N will be 100. Do I have the first term? I do, that is 3. Do I have D? No, I don't have D. However, to find D, we take two consecutive terms. So like in this case, let's say 2 minus term 1, and we're going to get, but it could be term, I don't know, 93 minus term 92. It will give me the same number, two consecutive ones. But here we have 3 and 10, so that means 10 minus 3 will give me 7. Therefore, the value of D is 7. And all we do, we replace the numbers with the letters with numbers. So N is 100. So that is saying I am finding the sum of the first 100 terms. That's all what it means. N means how many terms I'm adding, divided by 2, multiply 2 multiplied by A, which is the first term, 3, plus bracket, and again, number of terms, 100 minus 1, close bracket, and multiply by the common difference, which we did find is 7. And all we have to do, put all of that in the calculator and press equal, and we know that the sum of the first 100 terms will be 34,950. So that was nice and easy. Let's have a look at the next part of this question. The first, the fourth, and the n terms of this sequence, so this sequence here, are the first 3 terms of geometric sequence. Okay, let's write that information. So the first, the fourth, and the end. Okay, of this arithmetic sequence, so this is arithmetic sequence, add the first 3, so they become the, let's maybe write it a little bit further down, they become term 1, term 2, and term 3 of geometric sequence. Okay, and therefore we have to find the value of n, meaning that. What term are we talking about here? Okay, so what is my first term? Well, it was given to me in this question, that was 3. What about the fourth and the n? So how do we calculate the terms in arithmetic sequence? That's my first formula here. So let's take that formula. So here, A means what? The first term. N means what? Which term am I looking for? And D, we know common difference. So that means that the fourth one will be what? First term, which is 3, plus bracket, oh, not N, we know it's the fourth term, 4 minus 1, and that multiplied by our D, which we know is 7. So when we, let's write that here actually, because the first is the first, the fourth become the second. So that means if we put all of that in the calculator, we get 24. Sorry, that's plus, and that's multiplies. I don't know why those numbers disappear. And then Tn, again, let's go. So A is 3 plus, and this time I don't have n minus 1, and multiply by 7. Now here we can simplify it a little bit, isn't it? Because we can multiply the bracket. So I will have 3 plus 7n, and 7 by minus 1 minus 7, and then together 3 minus 7 will be minus 4. So my third term will be minus 4 plus 7n. In order to find the value of the letter, I need to have an equation that include that letter. So my problem is that I'm saying, well, from the information I have, can I create an equation that have 2 sides and include letter n somewhere so that I can get it to the place where I have n on one side and number on the other side? Now, when it comes to those sequences, one of the things that we very often use to build an equation, in the case of arithmetic sequence, actually what we already look at, we use the idea of D, the common difference, and therefore we are saying we can take two, I'm sorry, my brain is jumping forward. We take 2 consecutive terms, we subtract, and we get the value. So for example, we can say the second term minus the first will be the same as the third minus the second, isn't it? Or in case what I was saying, that I can have, let's say, 93rd term minus 90. Doesn't matter. That's all D. Now, when it comes to geometric, we have the same idea, the idea of R. So that common ratio, meaning how much are we multiplying here? So in this case, we take 2 consecutive terms, but we divide. Right? And then again, 93 divided by 92. So we get the idea. So that means that's what I can use here to create that equation, because on one side of the equation, I can take term 2 divided by term 1, which will be what? 24 divided by 3. And on the other side, I can take term 3 minus 4 plus 7n and divide that by term 2, which is 24. Isn't it? We can do that here to build that equation. So how do we solve it? It's a fraction equal fraction. Either we can cross multiply it, or we are saying this where a letter n is. We want to eliminate the denominator. How do we do that? We multiply by that denominator and we multiply both sides. So therefore I have 24 multiplied by 24 divided by 3. On the other side, I have minus 4 plus 7, and I take my 4 to minus 4 to the other side. Therefore, I change the sign plus 4, and then I am left with 7n, which means what? 7 multiply by the value of n. So if I want to get rid of that n, I divide both sides by 7. I put all of that in the calculator, and I get that n is 28. So that's one way we can solve that. Or the other way that we can solve that, I'm saying to myself, you know what? I have here, look at that. I have almost an equation here. If I could have the third term here, if I could have the value of it, then I could replace that with a number. So then we are saying, just let me remove some of these drawings. So I'm saying, can I calculate that third term in geometric sequence? Let's have a look. So here we have in our table a formula for a term in geometric sequence. So let's see whether we can use that. So the third term will be what? The very first, which is 3, multiplied by the ratio. Like we said, to find ratio, we take, let's say, second term divided by the first term. So therefore, we find that our ratio here is what? 8, isn't it? So multiply by 8, and then n, which is 3 minus 1, and we put that in our calculator, and we get that term 3 is 192. Therefore, we can replace that with a number, 192 equal minus 4 plus 7n. Now, yeah, obviously, that's kind of quicker, isn't it? We take 4 to the other side, we change the sign, and then we are left with 7n. And again, to find the value of n, we divide both sides by 7. We put that in the calculator, and we get the same answer, 28. So that's what I'm saying. Any way you're going to go here, you will arrive at the answer.